Hello, I am Pawan and I am from 7th Sem CSC B section. Today, along with my batchmates, we are going to explain NeuroCardioAI and AI-based human heart disease and brain tumors detection using CNN. Thanks to our project guide, Dr. Shivangauda GM sir, to guiding us through our project, and also thanks to Supriya MK ma'am as guiding us project coordinator. Next, I am going to give you a quick introduction how our project works and what it is built on. Majorly, brain tumor involves abnormal growth of cells in brain, which can be either benign, that means it is not cancerous and it does not spread, or malignant. Malignant means it is cancerous and cells spread. This leads to symptoms like headaches and seizures and problems related to brain. And also, heart diseases also are leading global cause of death. They are unrecognizable until they reach a serious issue. So diagnosis of these two issues, majorly problems, depends heavily on diagnostics or radiologist. They uses MRI or CT scans to detect brain tumors and they use ECG signals and so echocardiography or angiography to disease any heart related conditions. Both diseases demand an early and accurate detection, which is currently time intensive and heavily dependent, which require expert human analysis. If Also they are majorly prone to human errors. If not detected properly, they can be affect patient treatment. As I already told, traditional diagnostics like MRI and ECG are accurate, but they require expert analysis. Also, they are time intensive. And here, in recent years, since artificial intelligence has revolutionized medical diagnostics by providing automated, accurate, and fast disease detection, so we are also here using AI and machine learning models like convolutional neural networks, which provides automation, speed, and high accuracy in medical imaging. One of the powerful tools for this is convolutional neural network model, which is a deep learning specially designed for image recognition tasks, which can be used for image detections like MRI scanned images or electrocardiography signals. Next, algorithm and design. Algorithm and design, we will explain how algorithm is designed to build our project and correction and validation, how our project works. This will be continued by my project teammate Sujay Devraj.
Myself, Sujay V. Devraj. I am here to explain about the algorithm design of our project. Our algorithm is designed to detect the brain tumors and the MRI scans and MRI scans and the heart disease from the cardiac image using CNN. The process starts with the data collections. The data collections includes the MRI scans for the brain tumors and the echocardiograms for the heart diseases. Then comes to pre-processing. We when we resize the images here we resize the images like 128 into 128 or 224 into 224, and we normalizes the pixels values and the uses the methods like rotations, zoom, flip to increases the data set. And for the label encoding, we converts the categorical labels such as the tumor type or the heart conditions into the numerical stats to understand to the CNN. And the CNN architecture uses the pre-trained models like the efficient net BO for the extracting features, and it also adds the extra layers like the pooling, dense, dropout, and the softmax for the final classifications. In the training loop, we handles the imbalance data with the class weights, adjust the batch size data with the weights, and we also resizes the epochs and also tracks the validation losses. And finally, for the evaluation, we test the model on a new data set and generate the confusion matrix and prepare the classification report. Our algorithm is also designed to be efficient in a time and space. For the time efficiency, and we use a pre-trained model to reduce the training time and compared to training from the scratch. and the use batch processing and the GPU accelerations, which helps in speed up the computations and early stoppings, and the learning rate reduction helps to prevent the overtraining, which saves the epochs and the time. For the space efficiency, resizing the input images reduces the memory usages, and we uses a GPU for the memory growth options to prevent the system crashes while handling the large data sets. The data generators are used to load the images in the batches rather than loading the entire data set at once, and which saves the memory. And the this slides explains the functional requirements and the edge cases handled. Functional requirement, our model supports for the binary classifications and the multi-class classifications, and it also performs the real-time predictions. For the edge cases handles, it works with the image of the different types of tumors and orientations and resolutions, and it also handles the imbalanced data set by applying the classes weight during the training. And the next slide is correctness and validation, and this will be continued by our batchmate Ritesh.
Hello everyone, myself Ritesh. Now I will explain how we ensure that our model's predictions are accurate and reliable by using proper validation techniques. So the metrics used are: first one is the accuracy. It means it measures how many of our predictions are correct compared to the total number of predictions. It gives a general idea of how well the model is performing. Second one is the precision. It focuses on the quality of the positive predictions. That is, it shows the fraction of correctly predicted positive cases out of all cases that were predicted as positive. It is important because if the model predicts too many false positives, it can lead to unnecessary anxiety or incorrect treatment. Third one is the recall. It measures how many actual positive cases the model correctly identifies out of all true positive cases. It's useful because missing a positive case, especially in medical diagnosis like brain tumors or heart disease, can be dangerous. Fourth one is the F1 score. It is the harmonic mean of the precision and recall. It balances the two and helps us understand how the model performs in situations where there is a trade off between false positive and false negatives. Next, fifth one is the confusion matrix. We use confusion matrix to visualize how the model is making predictions. It shows how many cases were correctly classified and how many were misclassified. Next is the validation. For validating our model's performance, we split the data sets into two parts. That is, first part is 80% for training the model and 20% for validation to check how well it performs on unseen data. We use the validation loss to guide early stopping, which helps prevent overfitting and ensures that the model does not just memorize the training data but generalizes well to new cases. Next is the error handling. To ensure smooth execution and robustness, uh, we implement several error handling techniques such as we skip the invalid files or files that were not images to avoid crashes. In case of GPU memory issues, we use CPU fallback or limited memory growth to prevent errors. We also handle small batch sizes during prediction to avoid tensor copy errors, ensuring that the system works even with the limited resources. So next, I hand over to my teammate for explaining the flowchart of our project.
Good evening, everyone. Myself, Suhas MK, and my topic is about a flowchart. In this flowchart, we can see the users will come to for and we'll see the user access system. In that we have two options: one for a brain tumor to upload MRI scans, or for a heart disease where you can upload ECG signals or a manual input. Both disease like brain tumor or a heart disease go through a same pipeline, like for a data preprocessing, AI-based disease prediction, result interpretation, additional testing if required, or a diagnosis confirmation and a final report by an expert or a doctor. And after that, the end of a AI prediction process. After this, the output. This is the output. We have developed a website using React.js and Python.
And this in this we have given user two options of either they can choose brain tumor or a heart disease, whichever they want. This is the brain tumor upload section where you can upload the MRI scan, JPG or a PNG format image. In this, we have shown the one test case where meningioma test case is positive, where AI model has predicted a 95% accuracy with a confidence of 95%. And this is the confusion matrix with leukemia, meningioma, and neurotumor and a pituitary, where a neurotumor, where a model has predicted a 405 elements as a node tumor, which is great for node tumor detection. And this is the ROC curve, where class 0 is for glomia, and class 1 is for meningioma, class 2 is for no tumor, class 3 is for pituitary, where it is all predicting as we can see the AOC curve, we can tell that it is predicting better. And the expected outcomes is accurate disease detection. The system will effectively detect brain tumors and the heart disease from medical images with high accuracy in the data set that we have trained. Not if we take any other new data, the AI model can not work as it is. Like it works on a test or a trained data. Reduced diagnostic time. Automated analysis will significantly cut down the time required for diagnosis. Support for radiologists. This project is mainly created to may it act as an assistant or a tool for healthcare professionals in making faster and more reliable decisions. Earlier intervention, improved early stage detection will lead to timely treatment and better patient outcomes. User-friendly interface. We have created a simple and interactive platform will enable easy image upload and real-time prediction. Thank you.